All right, welcome back, everyone. Hope the quarter is going okay, and maybe things have lightened up a little. So most of these announcements we already announced last week. So if you've seen them before, then you don't need to do anything. Yeah, symposium. Please RSVP. Otherwise, we can't guarantee food for you. As always, our link shortener is l.acmcyber.com, and just go /symposium to RSVP. It's like less than a minute to fill it out. E1, MD, malware defense, enroll. So the class isn't empty. It's a cool class. CCDC. If I guess this is just an interest form. You're not committing to if there's only I think it's the team size is 8, then you're like forced to commit. This is just for us to get a sense of who wants to do it or perhaps to do it in the future, because the date this year is a little unfortunate, conflicting with LACTF. But yeah, please do this soon. We're gonna close the forum after Cyber Lab this week. So yeah, l.acmcyber.com/ccdc dash interest. And then yeah, so Cyber Potluck, it's this week, this Saturday. So yeah, come out to the university apartments. It'll be at Arnold's place, which is 625 Lane. Yeah, it's the address will be on our Discord. But yeah, so RSVP, so we know how much like burgers and hot dogs to get, and then feel free to bring your own special dish if you like to cook or stuff. I will try to make something, no promises, but yeah. And then the Cyber X ICPC X AI X Cloud, that's like half the committees there. We'll be running to Sawtell or busing if you don't want to run, and we'll get dinner there together. So this is a little further out. So next week, Friday, can RSVP here. Just gives you some more info and gives us a sense of how many people are coming, or whether to wait for people. And then of course, the unofficial cyber dinners. If you stick around till 7:50, we usually get dinner together afterwards at like the Nev or Beef Plate or something. So yeah, it's a good time. Okay, with all that out of the way, I'll pass it off to Ronak to talk about bypassing SAML.
Hello, I'm Ronak, and I'm here to talk about silly SAML security shenanigans spanning signature circumvention. Hey, just like stuff that can go wrong in the SAML protocol. So first of all, I guess let's start about what is SAML. So this is what SAML actually stands for, Security Assertion Markup Language. And the gist of what this is that it's a protocol used for single sign-on. So I guess the example scenario is let's say, I don't know, you're an institution like UCLA, and you have a ton of apps that all of your people need to use, all of your students need to use. You have Google Drive, you have Brew and Learn, you have I don't know what else we use, like my UCLA, Gradescope, whatever. There are a ton of applications that all the UCLA students need to use. And the thing is that all of you don't want to really provision credentials for every single person across every different service, because that's not really scalable. So there's this thing called single sign-on, which is you can use one sign-on thing, you can use one sign-on page to sign into every app. And the protocol for hooking up this sign-on page to every single other app is the most common protocol is called SAML. And yeah, and just some history about SAML. SAML has, according to Wikipedia, it's undergone one minor and one major revision. And the last revision was in 2005. So this is the most bleeding edge protocol. There are so many amazing stuff with this. It's amazing protocol. So I guess before we dive into some more stuff, let's talk about some quick cryptography background. So I guess in the rest of the talk, I'll mention a few terms, and this is just some definitions. So if you've heard of a public-private key pair, there's this people will sometimes refer to the public key which is like the key that everyone can see. People refer to that as like a certificate. Uh, and then there's this concept called a signature. The gist of a signature is that like the creator of a document signs their document using their private key, and then anyone looking at that document can use the public key to verify this, to verify that the document came from the document creator. And like when they verify it, they can make sure that no one really tampered with the document. Like the document is in the original form that the creator made. And like the cert or public key, like this thing is known to everyone, and the private key is like by name, it's private. Only the document creator has it. So that's what a signature is. And then there's also another concept called a hash. So like just like the basically what a hash is that it's just some way of mapping like a lot of bytes, like a big document or a big message or just some large amount of data. A hash is just a way to map that big data to like to some small like identifier, like some small 16 bytes. And like the way a hash is constructed is that you're not able to like given these 16 bytes, you can't really find the original document, but like given the original document, you can find those 16 bytes. That's basically what a hash is. And as you can see from this check mark here, it's approved by our cryptography expert, Arnav Vora. All right. So I guess here's like a quick rundown of the SAML protocol. So like you can get an idea of like what it's doing and like what potentially we might want to attack. So the gist of SAML is that you have three sorts of parties. Like you have the application page, so this could be like brew and learn. And then you have the IDP. The IDP is like the identity provider. This could be like UCLA's thing. I think we use Shibboleth or something. It could be if you've heard of Okta, like Okta is another IDP. There are like a ton of these. I think Google is also one as well. And then also in addition to the app to like the brew and learn page, like the front end of the browser running brew and learn, there's also like the brew and learn server, like the application server. And these are the three main parties involved in this. So when the front end wants to log in to like when they want to log in to their like using this site, what they'll do is that they'll first redirect to the identity provider, like using a browser redirect. And then after they redirect to the identity provider, the identity provider will allow the user to log in. So this is like you typing in your credentials in UCLA when it tells you like to log in. And then after that, what the IDP will do is that it will send a SAML document with all of your information to like the application server. So like in the case of Brew and Learn, the IDP would send like your email and your name to the Brew and Learn server. And the SAML document, it also contains a signature. So this application server can verify that like the SAML document came from this identity provider and not from someone else trying to log into someone else's account. So that's like sort of like the gist of SAML. And then like after this thing verifies the SAML document, it'll tell the front end that the user is logged in, and then now the user can like go and do their actions. So I guess like with this whole flow, the main thing that we probably want to try attacking with SAML is this step over here, verification. Because if we can like attack this verification step, what we can do is that we can just send whatever document we want to the app server, like, and we can sort of pretend to be any user we want if we're able to like, I don't know, like forge the signature or like trick this verification process. So now let's just dive into some common vulnerabilities with the SAML protocol. And TLDR, the main vulnerability is that SAML uses this thing called XML to represent its documents. So if you don't know, XML is like, have you heard of HTML before? Yeah, no. Yeah, XML, it's like basically HTML. It's not the same, but it's like basically that. But it's like really, really cursed. Like there are just like a lot of really weird stuff that are in XML that a lot of like SAML libraries don't really like handle correctly. And we can sort of take advantage of these to sort of attack a lot of SAML implementations. So the first like thing right off the bat is just a feature of XML. Like this is something that like some guy in a room sat down when making XML and was like, yes, I want this to be a feature of my document language. So there's this thing called XXE, external XML entity. I think that's
Hmm.
what it means. It might stand for something else. But basically like in your document, in your XML document, like it's normally like a tree where you have like an element and then it has children element and so on. But what you can do is that you can just like declare this thing called an entity. And this entity, like you can sort of just like sub it into random places in your document. And like this seems pretty harmless, right? Like, like I want variables in my document if I don't want to repeat the same information multiple times. Like this seems perfectly normal, at least it did back in the 90s or something. But however, what they didn't realize when creating this was like there's this thing like you can cause a DOS using this, like a denial of service attack. So basically, like if you declare one entity to be like just some string, and then you declare another entity to be the string, the string, the string, the string, the string, and then we declare another entity to be this one, like repeated a bunch of times, and so on. Like you end up like causing the parsing of this document to take way longer than it took to make this document itself. So an attacker could just send like a document with like some linear length as an attacker would do, but the person processing this document would have to spend an exponential time processing this because like everything just keeps like accumulating and this can just like cause your servers to crash and no one to be able to log into your app. So this is already like pretty bad, but like TBH, like I don't really care about a DOS, right? Like with a DOS, all I can do is really I can just take down the service for a bit, and then after a while they're gonna figure out what hit him, and then they're gonna like I don't know like disable this thing, and I couldn't really accomplish anything. So like a DOS is pretty significant, but it's not like the limit of what we can do. Another thing that we can do is that like the same guys who made this entity thing, they also just decided that for some reason XML should have the ability to like embed the result of an HTTP request to a different site in it. So like for some reason like they decided that you should be able to make requests to HTTP services inside of XML using the entity system using the system entity. And the thing about this is that this is really bad because like making HTTP requests is means that you can like make requests to anything inside of the internal network of the application. Like a lot of applications these days, they're sort of developed with this microservices architecture, which means that like it's just a bunch of servers, just like the application server is implemented with a bunch of mini servers, just like all running. So like I don't know, like if the SAML stuff was running in the authentication microservice service, all of a sudden you can just start making requests to like the delete user microservice or something. I don't know. So this is pretty bad, and uh yeah, this is and there are like a ton of other things you can do with this. Uh in some languages like PHP, they've just decided that a URL could be equivalent to just executing arbitrary code. So that's also a problem. And like the list goes on for XXE. I won't go into it more, but this is like just the fact that they use XML itself is really bad. And it's going to cause like a lot of vulnerabilities. So now, like moving on to the second main vulnerability. So this vulnerability, XML signature wrapping, just like a context, like I think it was mainly discovered around like 2010 or so. And it was like discovered in basically every single XML implementation that existed. So this was a pretty serious attack, and it affects tons of libraries and like it's still ongoing. Like I think people are still finding this vulnerability in different libraries because it's just so general and there's so many ways that this can arise that they still haven't found every possible instance of this yet. So the gist of this attack is like, so this XML document is like a tree. XML is sort of structured in a tree where you have like a root element, then that has children element and so on. And in this tree, you sort of have two types of elements. You have your assertion element. Your assertion, what the assertion has that it has like a signature to verify this assertion. And then it also has like all of the claims about the user. So this assertion has stuff like the user is named Bob. And it also has a signature saying that like like Shibboleth said that the user was named Bob. It wasn't just some random person who said this. So like this is roughly how the SAML is structured. And the way that verification will work is that you'll first like find the assertion, and then you'll find the signature, and then you'll sort of just like compare the assertion's body to the signature to like validate it. However, what people found out is that because these are like two different steps of extracting out a signature and extracting an assertion, they figured out is that like you can actually game the system. So there are many situations where this could occur. This is by no means like the only one. But what they figured out is that like you can start with like with a valid signature and assertion, and then if you just manipulate XML a bit, like if you move an assertion out of a body and a signature into a body or something, or like it depends on the XML framework what you do. What you can end up doing is that you can set your signature to validate one assertion, and the signature will validate this assertion correctly. Like the IDP said that my name is Bob, and the signature that came from the IDP says that my name is Bob. However, what I can do is that I can like hide another assertion inside of here and saying that I'm actually the admin, I'm not just Bob. And a lot of these SAML libraries will actually like fall for this because these are two separate steps. And like when retrieving the assertion over here for verification, it might be different than retrieving the assertion for the actual like using the SAML document. So this is like a pretty big issue, and it's occurred in so many different SAML libraries. And yeah. So I guess now on to vulnerability 3, parser differentials. So I guess just picture this. It's like a happy day at GitHub. Uh, you're at GitHub, you're working on the Ruby backend, and your boss tells you, hey, we want to switch from using our homemade SAML library to this public library called Ruby SAML, so that I guess we don't have to maintain our own SAML stuff. So the GitHub dev is like changing GitHub to work with Ruby SAML. And but unbeknownst to them, Ruby SAML actually has like a bit of some shenanigans going on inside of it. So just some intro to some stuff. Ruby SAML is a library written in Ruby. Ruby is a programming language. It's a library written in Ruby to handle SAML verification, like specifically on the server side. And this library, Ruby SAML, in order to parse the XML documents that we saw earlier, they actually have two parsers to do this. I don't know why they have two parsers, or this is why they have two parsers, but so they have one parser, RexML, which is a parser written purely in Ruby. So this is like the parser that they wanted to use this whole time because it was written in Ruby, and like I guess it's just nice. But the thing is that like some what? uh some like halfway through developing this library, what they realize is that this RexML parser, like it's kind of like terrible. Like it doesn't support half of what they want. So they decide to introduce another parser, Nokogiri, which is a more featureful XML parser. And I guess this parser, it just wraps a bunch of other like C libraries to do the parsing. So like what ends up happening is that like they start out using this RexML, and then they start like trying to use Nokogiri in some places, and then now they're currently trying to phase out RexML, I guess. So there's just like a lot of really weird stuff happening here where they have two different XML parsers. And the thing about security is that when you see two different parsers being used to parse some input from the user, your brain, your spidey sense should be immediately tingling. You should be thinking about parser differentials. So I guess what is a parser differential? It's basically like when two parsers parse the same thing as different things. So like the same document might be viewed one way by RexML and a different way by Nokogiri. And this usually has like a lot of security implications. It's not just in SAML. So I guess before we jump into the specific parser differential that like was happening, we can talk like let's talk about like the actual SAML document itself. So I was just talking abstractly about the XML, but this is what the XML actually looks like. So you have like it all is wrapped in this response field, and then you have some status thing over here. The status, like, I don't remember what it has. It just says whether it was correct, whether the authentication was correct or not. And then like the juicy part, this assertion. So you have this like assertion over here, and inside of the assertion, you have this signature thing, and then you have your claims over here in subject. So subject has like your name and everything else. Like your subject would say, "Hi, my name is Bob," uh, and then and then what you would do to verify this is that you would look at this signature element, and then the first thing you would do is that you would take this subject element and then hash it. Then after you hash it, you would compare it to this thing called digest value. So this is just to like verify that this digest value maps to this. And then after you verify that this digest value maps to like all of your claims, what you then do is that you then verify the signature on this digest value. So the identity provider, UCLA, what they'll do is that they'll sign this digest value, and the signature of this value is written over here. So the next step in like processing the SAML is to verify that the signature of this is equal to this. So that's like roughly how the SAML works, and that's roughly what parts of the document are which. So just to recap, this is the claims, this is the hash, and this is the signature of the hash. So the thing about this is that like, oh, why is that? Sorry. So what ended up happening is that like in their process of like I don't know, like writing this library, they somehow ended up with Nokogiri extracting out this element and this element, I think. Yeah. So Nokogiri extracted out the assertion and and the and like the signed info and uh and then also the subject. So Nokogiri extracted out like the signed info and the subject. And then to extract out this specific hash and the signature of the hash, RecML was used to extract out these two things. So like this is kind of problematic because if we can make one of these parsers see one thing and another see the other thing, we can trick one of them into computing the signature of something completely irrelevant, and the other one to just be like, and the other one to provide the application with like our malicious credentials. So that's exactly what people figured out how to do. So like people figured out some really like crazy thing. This was discovered independently between two people. One person just like was a crackhead and just thought of this, and another person used this thing called a fuzzer uh to just like try out a bunch of random inputs until they got something that worked. Uh, so what they figured out was that like if you put a how did this thing work? Okay, so if you put like assigned info over here, so it's like if you had your original document with your assigned info, you could put your whole signature up in the status, and if you put it up in the status, I think it's like Nokogiri finds it, but RecML doesn't. So it's like only one of the parsers sees this thing, and then the signature value over here, it's extracted with RecML because that's just how they implemented the library. When checking the signature value, they're checking that with RecML. So what you can do is that you can put the signed info that you got from the IDP, like the actual signed information, like the actual like signature stuff. You can just put the IDP signature for their own data over here, and then like over here and over here. And then this will pass the signature check. So it'll say that like, yes, this document did come from the IDP. And then now to pass the hash check, you can like you can just put your own hash in here, and since this hash isn't getting verified because we tricked the parser into verifying this hash, you can just put in the hash of like whatever assertions you're trying to claim as. So you can put the hash of saying I am admin instead of the hash of saying I am Bob. And all of a sudden, like we've tricked the signature part and we've tricked the hash part separately. And like when we combine these things together, we're able to both trick the thing into believing that the document came from UCLA and also into believing that I'm the admin and not Bob. So this is like the attack that was targeting Ruby SAML, and this is a pretty bad attack because I mean I'm pretty sure this was like available for many years, and GitHub Enterprise is used by a lot of very important enterprises. So yeah, pretending that you're someone you're not in GitHub Enterprise is pretty bad. So I guess like the aftermath of this attack, the vulnerability main like one of the main impactees of this vulnerability was GitHub, because GitHub's like a very prevalent application which uses Ruby SAML as their in their backend. So it definitely impacted them, although like thankfully that they had no evidence that anyone actually exploited this. And then like the merge fix that was proposed and eventually done to fix this whole vulnerability. To fix this, what they did is that they just added a blacklist on certain XML attributes and then like added error checking for like errors on the parsers, because in this document, like one of these parsers was silently throwing errors, but just that no one was catching them because like the errors didn't actually prevent the function from running. The errors just sort of hid in the background. So to fix this, like they added explicit checks for XML errors. Just quick question. Do y'all think that this is like a good fix, or like that there is still attack surface? So yeah, I don't think this is a good fix either, TVH. Like the core issue is that there are two different parsers in play, and the fix is to just like add on random patches. Like, of course, there's obviously going to be different vulns. So I guess like stay tuned in the next few years when like someone finds another vuln on this, because it's honestly inevitable. And then also in addition to this, there's also a lot of increased security scrutiny on Ruby SAML. Like this library, they're sort of just operating with like no one really cared about security at this when working on this library, which is ironic because this library is used for security. And I guess one recent update, Ruby SAML was trying to switch some other thing to Nokogiri. And some GitHub issue, like they were proposing switching something to Nokogiri XMLSec, which is some other part of Nokogiri. And then thankfully, like this guy, A Hacker One. By the way, A Hacker One is like that name sounds pretty like like who is that guy? But that guy is actually kind of the goat. He's discovered like many different vulnerabilities on Bugcrowd and is actually the one who blooded the vulnerability. So this A hacker one like saw this and was like, "Hello, please do not do this. It's dumb." So like I guess this is one good side effect of this vulnerability. Like people are actually looking at this library more and making sure that like they reduce their attack surface. And then just I guess beyond like so those are three different vulnerability categories. Is that it? Well, no, SAML library authors are always trying to find the next way to mess up. So like there are a lot of different vulnerabilities that they code up. There's like not checking certain fields in the SAML. Uh yeah, I forgot which fields exactly, but like there are some fields that you definitely need to check. Like you need to check that there are signatures on everything, and sometimes they don't check that. Also another thing is that in the SAML document, like there's an option to provide the public key used for signing inside of the SAML document itself. Now, the problem is that if you can specify the public key in the document, well, you can just put your own public key, right? So people keep making the mistake of trusting the public key inside of the SAML document. So I guess just like don't trust random inputs. And then also another one that's pretty prevalent is like using C to parse SAML so that you can be really fast. But the thing is that C has a lot of memory safety issues, which then like will not which then introduces your SAML thing to memory safety issues, which is really bad because like SAML is pretty like unprotected, like it's supposed to take in lots of inputs. So there are memory safety inputs in SAML, then like that's really bad. So there are like tons of ways for people to mess up. And as this is a recent one, I think this one might still be an issue, but yeah, like there are a lot of ways to mess up, and this is by no means it. So yeah. Any questions? Yeah. Yeah. Actually, yeah, that's a pretty good lesson. And I think they took that lesson to heart in like there's this new thing called OIDC. OIDC, I believe, uses JSON, I think. Yeah. So like so there's this new single sign-on protocol that they've tried to learn from that. And I hope that gets adopted because if that gets adopted, then we don't have to deal with that anymore. Yeah.
For that third one, it did seem to rely on having a valid signature from the one with the signature key. But doesn't that one like just communicate directly with the end server, like, or does it send it back to, or how would you get a valid signature?
How do you get a val simulator? Oh yeah, so I guess to clarify what's going on. So when I say like the IDP page slash web server is sending this to the app server, the IDP server isn't actually directly sending it to the server. What they're doing is that they're sending it to your client,
Oh,
which then redirects to the server with that as a payload. So if you just like intercept it on your client, you're actually able to see the SAML thing.
oh.
Yeah. Any more questions? Yeah.
What's the name of the user again?
A hacker one dash secure SAML, I think. This isn't actually like I think he has like a different alt for every single project he audits because they're referred to as a hacker one on like the bug bounty sites, and a hacker one dash secure SAML like is only like the only thing this person does is SAML, which like I mean I'm not gonna judge, but like I feel like they probably do more than just SAML maybe. So yeah, I think they have like different alts for like all the different projects they work on. Unfortunately, github.com/ahacker1 is an organization, so I don't think that's an actual account. Yeah. Anything else? Any other questions?
Let's give an answer, Rona. And yeah, with that, we'll go into our usual Cyber Academy groups. So fundamentals up here and then advanced group in the back.